Hello guys. Okay, for today I would like to discuss the transformers for part 2. Okay, the learning outcome for this topic. First, students should be able to explain the principle of three-phase transformer. Second is able to explain three-phase transformer connection. Third one is able to calculate the phase and line voltage, phase and line current, turn ratio at the primary and the secondary side of the three-phase transformer. As an introduction, almost all the major power generation and distribution system in the world are using three-phase AC system. There are two ways of constructing the transformer of three-phase circuit. First is use three single-phase transformer are connected in three-phase span. Second is make a three-phase transformer consisting of three set of winding wrapped on a common core. The three-phase transformer on a common core, which is the second method, is the preferred because it's more lighter, smaller and cheaper and slightly more efficient. A three-phase transformer consists of three transformers either separate or combined on one core. So there are four possible connection between secondary and primary of the three-phase transformer, which is Y-Y connection, Y-delta connection, delta Y connection and delta delta connection. This is the connection in the transformer. Winding transformer. This one is delta delta connection. This is incoming or at the primary side, and this is at the secondary side. The connection here is show that the delta connection, and for the secondary side delta connection. And for second possible connection is the star delta. This connection is for star and this connection for delta. And for the third one is star star. This connection for star and star. And the fourth one is delta star. So this connection for delta and this connection for star. For the turn ratio for the three-phase transformer connection, for example here, for YY connection is V line 1 over V line 2 equal to A. A is the turn ratio. So V line 1 equal to set 3 V phase 1. And V line 2 equal to set 3 V phase 2. So we can cancel out this set 3, then we'll get A. So for YY connection, the turn ratio is V phase 1 over V phase 2, or V line 1 over V line 2 equal to A. For the Y delta connection, for Y, the primary one is Y. So VL1 equal to set 3 V phase 1. And for V line 2, because the secondary is delta V line equal to V phase. So V phase 2. So here equal to set 3 A. That's why we got set 3 A. For delta Y connection, so delta Y connection VL1 equal to for delta is VP1, and for VL2, for Y connection, for secondary one is set 3 V phase 2. So set 3 V phase 2. So we will get here VP1 over VP2 is A divided by set 3. Then for delta connection, we know that V line 1 equal to V phase 1 and V line 2. So V line 1 over V line 2 equal to V phase 1 over V phase 2. So equal to A. Okay. So here we can see that for YY connection, okay, for YY connection and for YY connection and for delta delta connection, the ratio is same A. Okay, but for Y delta and delta Y, okay, we are a bit different because we have set 3A and A divided by set 3. Okay, now we see example 5. What should be a rating, okay, for voltage current and turn ratio of the three-phase transformer to transform 10 MVA from 230 kV to 4160 volt if the transformer is to be connected in YY, YD, DY and DD. So this is solution for example 5. Okay, for question A, what is the rating if the connection in YY? So firstly, we know the equation S total or S three phase equal to set 3 V line I line. Okay, and we know the S total, okay, the rating in three phase power, okay, and the V line at the primary side or V line 1. Okay, so we will get the line current at the primary side is S divided by C3 VL1 is 25.1 M. Okay, as we know that for Y connection, okay, at the primary side is Y connection. So for Y connection, line current and phase current is same. Okay, so the value is same lah, 25.1 M. Okay, now we see at the secondary side. For secondary side, S divided by 3 VL2. Okay, so VL2 is 4160 volt. Okay, the power is remain same, okay, as the primary side, and we can calculate and we get 1388 M. Okay, and to get the phase current, okay, for the secondary side, okay, we know that secondary side is also in Y connection. For Y connection, I phase equal to I line, so the phase current equal to 1388 M. Okay, and for the SP or power in the single phase, okay, so we just divide S total divided by 3, then we will get the S in single phase. So what is the phase voltage at the primary side? So the given value is the V line, okay, at the primary side is 230 kilovolt. So to get the V phase, we divide by 3 and this is the value 132.79 kV. Okay, and for secondary side of phase voltage, okay, so we got V line voltage, V line 2, okay, sorry, V line at secondary side is 4160 divided by 3 is 2401.777 volt. So the turn ratio is VP1 over VP2 equal to 55.29. Okay. Okay, for question B, okay, what is the rating of transformer for Y delta connection? Okay, so firstly, we have to use this formula S equal to 3 VLIL. Then we will calculate the IL1. IL1 is S 3 phase divided by 3 V line 1 is 25.1 M. Because of the connection in Y, okay, so the phase current and line current is same. So the phase current also 25.1. Okay, for the secondary winding, okay, secondary connection in delta connection. Okay, the line current is S divided by Z3 V line 2 is 1388 M. Because of the delta, okay, phase current is not equal to line current. They need to divide by Z3. Okay, the line current divided by Z3, then we will get the phase current for the secondary winding or secondary connection is 801.36 M. Okay, and for the voltage at phase voltage at the primary side is V line divided by Z3 because of the line the connection in Y, so V line is divided by Z3. So VP1 is 132.79 kilovolt. And for V phase at the secondary connection, because of the delta connection, V phase equal to V line is 4160 volt. Okay, so the ratio, the turn ratio is VP1 over VP2 equal to 31.9. Okay, now question C is what is the transformer rating? Okay, for delta Y connection. Okay, so the same thing, you have to use this formula as total equal to Z3 V line I line. Okay, so calculate I line for the primary side is S divided by Z3 V line 1. Okay, so S is 10 MVA divided by Z3 230 kilovolt, so 25.1 M. Okay, because of the primary connection in delta, so phase current is not equal to the line current. So phase current is, you need to divide by Z3. Okay, so we get 14.49 M for the phase current at the primary side. For the phase current at the secondary side, because of the connection in in star, okay, in star meaning that phase current equal to the line current. Okay, so just use this formula and you get the line current and phase current at the same time, 1388 M. Okay, for the voltage, okay, phase voltage at the primary side, okay, we know for delta connection at the primary side, okay, V phase equal to V line equal to 230 kilovolt. Okay, and for phase voltage at the secondary side, okay, the secondary side in Y connection, so V line 2, okay, divided by Z3 is 2401.777 volt. Okay, and the turn ratio, we have to divide VP1 over VP2 is 95.79 ratio. Okay, now for question D, okay, what is the transformer rating for D delta connection? Okay, firstly, use this formula S total equal to Z3 V line I line. Okay, then calculate I line for the primary side. Okay, using this formula, S divided by Z3 V line 1 is 25.1 M. Okay, because of delta, so we have to calculate phase current equal to line current divided by Z3 is 14.49 M. Okay, same goes to the secondary side. Okay, we have to calculate the line current. Okay, line current, okay, S total divided by Z3 V line 2 is 1388 M. And for the phase current, we have to divide by Z3 because of the delta connection. So the current is 801.36 M. And for the phase voltage at the primary side is 230 kilovolt because V phase equal to V line for the delta connection at the primary side. And for the secondary side, V phase equal to V line 2 equal to 4160 volt. Okay, because the delta connection at the secondary side. So the ratio is VP1 over VP2 equal to 55.229. Okay, this is exercise 2. Okay, the exercise you have to do, okay, two questions, question 1 and question 2, and you have to submit to me through empty assignment. Thank you.